equation. Okay? If you know how far it falls, and it started out with no velocity, well, let's just write up the whole equation. Let's consider the tabletop to be our original position and that to be 0. You guys get to pick the reference point. That's one of the fun things about physics. We get to say that, hey, I'm going to call this 0. Okay, so up here, that is 0 meters. That's my 0 meter mark. So that goes away. That's 0. You already said that the original velocity in the y direction is 0. So guess what? That goes away. So if I manipulate this for any height or any drop in height, I can figure out exactly how long it will take anything to fall that far. So that's kind of cool. Because then I can figure out, is it really accelerating or decelerating in this direction? Or is it moving at constant velocity in this direction? Just by taking the same kind of points that you took on your last lap. Right? If I can figure out the horizontal speed here, and compare it to the horizontal speed there, and there, and there, I'll be able to see a trend. What measurements do we have to take? Think about that. I'm going to give you guys a couple minutes to think about how you would, what measurements are you going to need to figure out Vx, the velocity in the x direction at each of these points. Okay. Talk about that in your group. We're going to regroup in a few minutes. Hey guys, let's put our collective brain power here to try to design an experiment that will be able to tell us whether or not we've got a consistent velocity. Sammy?
Wouldn't you just need to find the time, because for the first equation you gave us here, it's like dx equals dx 0 plus axt, and then we know dx 0, which is like v o y or whatever, equals 0, and then the a equals the gravity, which is like almost 10, like 9.8. So we just need to find the time out of that.
Okay.
So we should conduct an experiment to find the time, right?
All right. Let's build on that. Now, are you talking about to find this direction?
No, you said like to find the vx, like over there.
Yeah. So the speed at the
yeah.
end. Okay. So I'm so glad we're having this discussion, because we said that the horizontal and vertical motion is independent, or they're independent of one another. And gravity, the little g, is only in the downward direction.
Oh.
So we can't mix those in. And you're going for a time. Can somebody illuminate how we might be able to find some of these times? You? Oh, were you stretching?
Yeah.
Oh, okay. This looks like I know the answer, but then yeah.
Well, you would have to use the other equation
Okay.
to find the time. So x equals.
This one over here?
Yeah, we use that equation first to find the time, and then use the time.
Okay, so how, obviously we got rid of these two, so are we going to be able to determine what this y is? How do we measure the y? Yeah, I mean that's just these distances in here are all your y values. Right? We call that y1, call this y2. and this flies 3 all the way to the ground. Okay, this out. And you claim, how would I rearrange this to find y all by itself? I'm sorry, t all by itself, thank you. Yeah. Y is already all by itself, isn't it? Okay, what do I divide by? Okay, so when, and then take square root. Okay, so I find that time is actually the square root of 2 times y over g. Okay, and you can measure y. You can measure that, that's no problem. We know what g is. That's good. All right, so we can get a time. Outstanding. What else do we need to know? What else do we need to measure? Distance. Which distance? Show me.
Vertical.
We've got the different vertical distances to get our time. Now we need the horizontal distances, yeah, to get our horizontal displacements. Okay? So this, whoops. So this might be your x1. This might be your x2. And this might be your x3. Okay. So we could use that, right, to figure out the distance it went in that time frame. That would give us a velocity. Sorry, displacement in that time frame. Okay. All right, that's good. That's good. And then we can see if the trend is that it's losing speed, gaining speed, or remaining at a constant speed. All right. Now, it's easy to figure out how to measure the y. How are we going to measure this x? It's tough. I'm going to kind of lead you on this one, okay? The fact that you knew you had to get those measurements is great. That's a great first step. Yeah. So we're gonna pick up there tomorrow as far as how to actually get those x's. The important thing I want you to know now is that you need them, and that you can find the times, and those times are going to be really accurate, much more accurate than if you were trying to use a stopwatch. Let's see what time we have. All right. So that should give us time to do one of 2 things. Some of you needed to finish off a lab report where you need to pull in all those pieces. Here's my problem statement, my hypothesis. Here's my procedure. Here's my data. Here are my conclusions. Some of you have not. I put together a little assignment on how to use these particular equations. It was a flipped assignment. I can either put that up on the board, or you can watch it on your phone with an earbud. And there were also some problems that went along with it for you guys to try. Okay? So why don't I put the video up for those of you that don't have something to watch it on, and the rest of you can work on either the lab or the video or the assignment. Yeah.
I'm kind of curious though, but like if you were doing the but don't you have to complete the 3rd phase of the lab to actually do the lab report? Because
yeah, we're gonna treat the 3rd phase tomorrow.
Oh, like
so
at a
just
separate.
worry about the lab report encompassing 1st and 2nd phase.
Okay.
What is the homework I signed on in Moto? I can show you what that was.
No, when is it due?
Oh, when is it due? I was gonna make it due tomorrow, but I'll leave it till Monday on that.
For what, the problems?
Yeah.
Okay.
Okay.
Is it FaceTime?
We're labs, right? Yeah. Cool.